So our next session is transactions, uncertainty, and trust in the voluntary carbon market. And this session will be moderated by my colleague, Kate Stoll from the AAAS Epicenter. So welcome, Kate, and the next set of panelists.
Thanks, Rebecca. We have a great session lined up for you here. And given the short time, I'm going to move right into our first panelist. Erin Sills is professor and department head for the Department of Forestry and Environmental Resources at North Carolina State University. So Dr. Sills, I'll hand it over to you.
Thanks, Kate. Thanks for the invitation to speak. Let me just do a sound check. Everyone hear me okay?
Sounds good, thanks.
Perfect. So I have been working on a different type of carbon offset than what you've been discussing here. If we go to the next slide, primarily looking at what's called REDD+, or reducing carbon emissions by reducing deforestation and forest degradation. And then the plus here means, in addition, enhancing forest carbon stocks to take carbon out of the atmosphere. So this is what's referred to as a nature-based climate solution. It's quite well integrated into the global approach to mitigating climate change. For example, most countries that have put together nationally determined contributions have included forests into their strategies for how they're going to reduce carbon emissions. Relevant to our topic today, REDD+ also generates offsets. It generates them for a sector such as the airline sector under CORSIA, for jurisdictions like California under the Air Resources Board. As I just mentioned, it's part of NDCs, and also in internationally traded mitigation options under the Paris Agreement. So REDD fits into all of those. What we know about REDD, though, largely comes from its role in the voluntary carbon market. And there have been REDD projects ever since the late 2000s, when the UNFCCC actually called for demonstration projects or pilot projects in this area so that we could, in fact, learn about how REDD could function as a carbon offset. So let's go to the next slide. And in this panel, what I wanted to focus on that we've learned from looking at those voluntary projects for corporate social responsibility or offsetting carbon footprints, what we've learned about the integrity and quality of REDD credits. And the framework that's typically used in the forest or the REDD sector is to think about these four things listed here. So first, and to me sort of foundational, is the additionality, or what economists would call the causal effect of having a REDD project on the climate. So if we compare the situation with the project, which is what we observed, to the unobservable situation that we would have had without the project, what difference did it make for the climate? Continuing on from there, then the second thing to think about is whether there's leakage from the project site. So whether it's more deforestation in other areas, it's displaced deforestation, or potentially positive spillovers through enforcement effects. But typically we're going to think about that leakage, the additional deforestation or the displaced deforestation. And the criteria would be that we want to either limit that, or if it's going to occur, document it and discount it from the credits that are claimed. Third would be then the permanence of those credits. Permanent sounds permanent into infinity, but under different standards or different methodologies or different timeframes laid out that we want to be able to guarantee that that carbon will be retained in the biosphere. And then last, co-benefits. So this has been really important in the REDD world because REDD is defined under the UN as reducing emissions from tropical forests. And so this is thinking about addressing the climate change problem. It's largely a result of fossil fuel emissions in the global north by reducing deforestation in the global south. And so there's been a large emphasis on thinking about whether we can do that in a way that also delivers co-benefits for other ecosystem services and for local livelihoods, and at least if we can do no harm in the process, so have safeguards that prevent negative impacts on local people. So again, I'd say the foundation of those is additionality, and what we've got here on the next slide is what are the factors that we found have been sort of undermining our attempt to generate high integrity and high quality red credits, specifically in the additionality space. And so threats, barriers, hurdles, whatever you want to call them, I'd say the main one is what I call adverse selection of sites and also methods. So adverse selection of sites means selecting a site to implement a red project where there wasn't much threat of deforestation, right? So it's a place where maybe conservation was the default, there wasn't a lot of development potential, wasn't a lot of access, so not a lot of pressure. That makes it very easy to hold down deforestation, so it makes it easy to hit your performance benchmark and succeed in that case, but it limits additionality. As the red offset market develops, there are a number of different methodologies and systems that are out there. And so to some degree, project developers can choose their own method. And logically, these project developers, as you all were discussing, they're seeking to make a profitable business, and or if they're a non-governmental or an environmental organization, they might be seeking to maximize the revenue they can bring in to support local people and biodiversity conservation. So they're going to pick both the site and the method that's going to maximize the credits that they generate. So one key threat. A second, I would say, that we can learn from experience in the forest sector is that when there's not full transparency in the sense of providing consistent open access information in a standardized way, that undermines the ability to check whether something is additional, to evaluate whether something's additional. And that has been a challenge here in the red sector, even though for most certification systems, there is an open access data policy. So you can see the information on the projects, where they are, what they're claiming in terms of how many offset credits they're going to generate. What's been missing, I think, is sufficient standardization and quality control on those data. So once you dig into them to try to figure out what's happening, you find out that although there's information there, it's a little bit hard to process and compare across projects. Wanted to flag that. Third point here is really sort of fundamental to everything we're discussing, right? We'd like to compare how we're affecting the world, what the world looks like, what carbon emissions look like, given the activities we're taking, relative to what would have happened without those activities. And that's a fundamentally unobservable other state of the world, right? So when we're trying to build up this counterfactual to evaluate the effect of RED or any other offset project, we fundamentally don't know what we're comparing to. We can't observe it. There are lots of methods for constructing that counterfactual, or business as usual baseline, sometimes called. But I would say there's been insufficient investment in the strategies and the data collection to construct a valid counterfactual. Let's go to the next slide here. So I wanted to highlight a recent paper that I was involved in that looked precisely at this issue of what RED projects are projecting, what would have happened, what would have been their counterfactual, so what they're using as the basis for claiming credits, versus an effort that we did later, coming back and looking ex post at those projects to really collect data on comparison sites, examine what happened to deforestation in those comparison sites, and construct what we consider to be a more valid counterfactual, what actually would have happened if we hadn't seen those RED projects go in. Next slide. So for this study, we looked at 27 projects across these countries. Here, I'm just going to focus on 18 sites where we had the best information on the baseline. And so again, all of these projects have information in the VERA registry about the projects, but there wasn't always complete information. So we're down to 18 projects where we had sufficient information to really understand how they had constructed their baseline or their projection of what would have happened without the RED activity, and therefore their projection of how many carbon credits they should get. So we could then compare that to our analysis ex post of what their impact actually was. Next slide. So here we have those 18 projects spread across all of those countries from Cambodia to Tanzania. I hope you can see the names here. I realize the resolution maybe isn't quite high enough. Let me walk you through the colors that you're looking at for each project here. So what you're seeing is across years, so from 2001 to 2019, this is the cumulative deforestation in each of these sites. And in each case, for each project, what you're seeing is there's an orange line that sort of shoots up, right? So that orange line is what the project developers said they were predicting would have happened in their site if they hadn't come in and intervened. So that's the business as usual, or the baseline that they're using to establish carbon credits. The red dotted line is what actually happened in terms of deforestation in the site, right? And then the dashed vertical line is when the project started. So if we look at any of these, let's get the top left one, we see that we're going along at a low level of deforestation, but the project developer says, oh, deforestation is about to take off. That's that big orange line shooting up. But instead the project came in and they held deforestation down to the red dotted line. So the difference between the orange line and the red dotted line is the credits they would claim. The blue is what we did in our analysis. So we came back ex post and we looked at comparison sites, similar sites to the red project site, and then we tracked what happened with deforestation in those comparison sites. And we built a weighted combination of comparison sites. And the blue line shows you what we predicted actually would have happened without the project. So what just came up in red is one project where you can see our blue line ex post, looking at all the comparison sites, we saw deforestation even higher than what the project expected it would be. And the deforestation was definitely higher than the red dotted line. So that one project in Peru really reduced deforestation and therefore reduced carbon emissions. But it's the one project here that looks like that. In every other case, the projects were over predicting how much deforestation would have occurred and therefore over claiming carbon credits. Next slide and last slide, I think. So summarizing what this means then for the carbon credits is these 18 projects together claimed that they could generate 89, there's a missing M here, million tons of carbon offsets. And they actually issued 62 million tons of carbon offsets. And then of those, 16 have already been retired. But when we do our analysis, if we calculate how much carbon per hectare there was based on the baseline information we had, and then we use our blue lines, our synthetic control counterfactuals rather than their baselines, we find that they've actually only offset 5.4 million tons of carbon emissions. So this is where you may have seen the headlines around some of this work, which was saying that 90% of the carbon offsets that were claimed, the potential credits, weren't real. We only found 5.4. Okay, let's go to the next slide, which is just the end. So I just wanted to point out that this issue then of really accurately calculating the baseline and the counterfactual for issuing carbon credits is fundamental, is core to sort of integrity and credibility of carbon credits. And we've had some challenges in the forest sector that I think can be addressed as we move forward with offsets in other sectors. I'll stop there.
Thank you, Erin. Appreciate it. Yeah, so now we will turn to Barbara Hea, who is director of the Berkeley Carbon Trading Project. So Barbara.
Hi. So, yeah, thank you so much for inviting me. I've learned so much throughout the day. So like Erin, I come at this from the offset side. I've been studying carbon offset quality for more than 20 years, studying the UN's Clean Development Mechanism, California's offset program, and several project types on the voluntary carbon market. So my goal is to consider possible lessons learned from forests and mine methane capture offsets that could inform the oil and gas sector. So thanks. So first, big picture, I and others have been studying offset quality over multiple generations of offset programs, and the quality of offset credits has been relatively poor across many different project types and programs, and the inflation of credits is often many-fold, meaning that often the actual climate benefit is a small fraction of the credits generated, as Erin described for red. Quality matters because credits can take the place of direct emissions reductions, especially when there's over-crediting, so they're even less expensive than direct emissions reductions. They can justify ongoing emissions such as selling carbon neutral guilt-free flights, and they can obscure societal progress in reducing emissions. For improved forest management, there have been quite a number of studies that have looked at this project type. It is generating around half of all credits from projects in the United States. And I want to highlight two issues. So for baselines, it's very similar to what Erin described for RED. The top 3 studies from led by different researchers have found similarly that there is that the baselines are highly exaggerated often, and that the likely program impact is a fraction of total credits generated because of adverse selection, enrolling lands that are naturally have higher stocks, or by claiming average stocks as the baseline, which is allowed even if the landowner wouldn't have harvested to that average. But verifiers have a hard time identifying that because of asymmetric information. And then the second issue, leakage, which we've already discussed in the workshop. For if you close an oil well, does that oil production just shift to somewhere else, is also an issue for improved forest management, where if you increase the carbon stocks in your forest by reducing harvesting, which is what most projects do, but you don't change the demand for timber products, that timber harvesting can shift to elsewhere. And work that we did found that for the most used offset methodologies in the US, that the ways that leakage is assessed is likely generating 50 to over 80% of the credits, or likely do not represent real emissions reductions. Staying on this slide, for mine methane capture, I want to highlight a different issue of perverse incentives for regulators not to regulate the industry. And for here, so the mine methane capture protocol in the US credits the capture and destruction, or capture for use, methane from coal mines that would otherwise, where the methane otherwise would have been released to the atmosphere. So I participated in an EPA workshop where on mine methane capture in the US, where the a representative from the Bureau of Land Management sort of assured the workshop participants that as the Bureau was considering whether and how to regulate and or incentivize coal mine methane capture from mines on federal lands, that they were taking California's mine methane capture offset protocol into account. And the implication, as I think Pedro mentioned earlier, is that if it's regulated, then those mine owners would need to pay for it themselves and wouldn't be able to generate credits because the credits would be considered non-additional. It's required by law. So the implication of this statement was that the Bureau was, by taking into account California's offset protocol, they were cognizant that if they regulated, then the mines wouldn't be able to participate in the offset protocol. We don't know what the real impact of California's program was, but there was a suggestion that it may have influenced regulation. So next slide. So back to avoided deforestation, or RED. It's the project type on the voluntary market that's generating the most credits. It's a quarter of all credits, so that's why all of the attention. And Erin mentioned some quality issues. And our group, we released this study a few weeks ago, and we looked at this list of quality elements of the 4 main protocols that are generating REDD+ credits on the market. And what I want to highlight here is that our team was surprised at how common problems were, at how far the project calculations were from published science. And I want to highlight sort of at the very end, we came together and here's one possible explanation of what is going on. And we sort of looked at the project documents and what's happening sort of under the hood. And our understanding is that the methodologies offer project developers significant flexibility in how they can do the carbon calculations. I'm sure it's to provide, allow for many different projects within many different contexts to participate. And project developers were using that flexibility to make decisions that led to more credits rather than conservative decisions, which is required by the methodology. And that the third-party verifiers were not ensuring conservativeness. And if you take a look at the offset market, I think this overcrediting is a key challenge in the structure of carbon offsets because there's a lot of uncertainty, necessary flexibility, asymmetric information, and uncertainty is being deliberated by a whole set of market players that all benefit financially from more credits. From the buyer who wants less expensive credits to the developer who wants to generate more credits for the same project. The verifier is hired by the developer, and the rule makers, the registries, are competing for market share. So our understanding and sort of looking at the way decisions were being made is that you have a whole set of decisions from the writing of the methodology through all the calculations to the buying of the credits, where they all lean towards more crediting, and that over-crediting compounds, and that's how you get this very high levels of over-crediting, like 5, 10, 15 times what's been documented in the literature. So next slide, please. There's been, throughout the workshop today, we've seen, we've raised a lot of different issues about in the oil and gas sector that need to be thought about in designing and considering methodologies. And others have said much more than I can say about all of these. So just reverse incentives, baselines, additionality, and maybe go to the next slide. We also, in terms of keeping oil and gas in the ground, you have leakage, additionality. And I guess just a last thought is, I think a key question is, given the challenges from other project types and the challenges raised today about uncertainty, perverse incentives, I think the question is, what oil and gas project types and well characteristics are amenable to carbon crediting by being able to reasonably well avoid overcrediting given uncertainty and avoid perverse incentives. And if not, I'll leave it there. I think that's a key question that I'm looking forward to discussing.
Thank you, Barbara. I appreciate that. And we'll go to our third panelist today, Virginia Palacios, Executive Director of Commission Shift, to share her perspectives. And then we'll jump into Q&A. So please feel free to start throwing your questions in the Q&A box. Virginia.
Hey, thanks so much for inviting me to participate. I'm the Executive Director of Commission Shift. We're a statewide nonpartisan nonprofit in Texas focused on accountability at the Railroad Commission, which is our state's oil and gas agency. Next slide. So we'll just talk a little bit about some of the different types of unplugged wells in Texas. And then I think we can have a deeper conversation about where this might work or might not work in Texas. Some of the regulatory solutions that we've identified at Commission Shift for addressing orphaned wells and sites in Texas, and what the whole accountability structure looks like at the Railroad Commission. Next. Okay, so we all know orphaned wells are wells without an owner. In Texas, they're wells where the owner has been inactive for at least 12 months. This is an example you're seeing of a well that blew out down in Refugio County, Texas. This is South Texas near the Gulf Coast, and sprayed volatile organic compounds all over the surrounding wetlands, killing all the vegetation. This landowner's father was after the Railroad Commission for years to plug these wells, and they just chose not to go out and deal with it. He passed away and she inherited the problem. She was after the Railroad Commission to plug the wells, and they still didn't do it until, well, even after this well blew out, she was asking them to plug all the wells, and they still didn't do it until she filed a lawsuit, and then they finally plugged the wells. Next. Inactive wells, of course, have an active operator. They're not orphaned. The operator is responsible for plugging. In this example, we see from Antina Cattle Company on the border of Ward and Crane counties, Texas. They started having wells, Chevron wells, that were leaking. And Chevron's been out there plugging the wells, but they're playing whack-a-mole. So as soon as they plug one well, another well will start leaking again. And so part of the issue that we're noticing out in the Permian Basin in particular in West Texas is that there have been profuse amounts of class 2 injection wells approved by the Railroad Commission in this region. And so there seems to be an overpressuring of the subsurface that's causing wells to start leaking. Next slide. And then, of course, there's undocumented wells that are not in the Railroad Commission's database. In this particular instance, someone found documentation for this well in the Midland Energy Library. This also happened to be attributed to Chevron, but once Chevron got out there, they found another hole about 10 feet away and claimed that one instead. Next slide. And then there's another type of well in Texas called a P13 well. And so the Railroad Commission has a process where they allow operators who drill oil and gas wells to then transfer the wells to the landowner as a water well. And even though state law defines an orphaned well as a well that the Railroad Commission permitted, that has no active operator and that is inactive, and these wells meet all three definitions of an orphaned well, the Railroad Commission has chosen to interpret the law differently and is not allowing either federal or state funds to be spent on plugging wells like this one. So this is a P13 well that's flowing at a rate of 400 gallons a minute. It has high levels of radionuclides and hydrogen sulfides coming out of the well bore. And it is 4 times saltier than the ocean. And it's created essentially a 60-acre saltwater lake out there in Pecos County. Next slide. This is a site that is about 1.5 miles south of Beamer Lake, again, caused by a P13 well. It's a sinkhole that's about the diameter of 5 football fields. And that's the landowner you see on the right. Every time it rains, the road opens up, and TxDOT is now talking about spending $27 million to reroute the road. Next slide. And so here's the other threat with unplugged wells, right? Now we have this new technology with geologic carbon dioxide sequestration. Of course, there's already been some carbon dioxide sequestration taking place with class 2 injection wells. I guess I wouldn't call it sequestration. It's more enhanced oil recovery. But if we start to significantly expand carbon dioxide injection throughout Texas, which we may do, and the state is on track to do that, there's a risk of having more well blowouts like the ones you just saw from unplugged wells. Next slide. And so this is just a snapshot of what all of these different well types look like. And so for orphan wells, Railroad Commission is supposed to plug those. Right now, there's close to 8,000 in Texas, and about 1,900 have been inactive for more than 20 years. So most of these are really kind of modernly orphaned wells. They're not all legacy wells. Out of the inactive wells, there's 113,000, and many of those are more than 20 years inactive. And then we look at the shut-in wells. There's about 40,000 of those right now. Those might come back online if the price of gas increases. With P13 wells, we really don't know how many are out there. There's about 2,000 on the Railroad Commission's list. Those are the ones that they know about and that they've verified, but there could be more. And so far, the Railroad Commission is saying that the landowner is responsible for plugging those. The landowner you saw on one of those prior slides, Skylar White, tried to plug a P13 well on his property. He spent $200,000 and still didn't finish. And so this can be pretty unachievable for most landowners. Undocumented wells, you know, some of the documentation we have of legacy wells that have been drilled in Texas since the late 1800s are in the hundreds of thousands. So it's possible that that's kind of the order of magnitude that we're looking at for undocumented wells in Texas. And then, sorry, this is kind of dipping down, but for marginal wells, there's about 71,000 close to marginal gas wells, and then 103,000 close to marginal oil wells. These thresholds are just kind of the data that we have available from the Railroad Commission. So 250,000 cubic feet per day and 10 barrels of oil per day on production there. Next slide. And so I drafted a report with a co-author, Megan Milligan-Bivin from True Transition, with a toolkit of 10 solutions for the Railroad Commission to eliminate orphaned wells and sites in Texas. One of the top solutions that we're advocating for is limiting inactive well plugging extensions. And so operators are supposed to plug wells within a year of the well being inactive, but the commission allows them to get plugging extensions almost indefinitely. Next is collecting the right amount of financial assurance. And so all we know is how much the Railroad Commission spends on average plugging wells, but they tend to plug the shallower wells that are cheaper to plug. And so if we had decommissioning cost reporting for the true cost of plugging by the industry for even some of the deeper wells, like the shale wells we have now, that would help us to calculate financial assurance correctly. And then finally, modernizing the financial assurance tools. So requiring full cost bonding. We've also recommended a sinking trust fund that the operator could use to plug their own wells at the end of the day. And you can find more on our YouTube channel or our website. Next slide. And so I think it's important to understand the accountability structure at the Railroad Commission. 66% of the commissioner's campaign contributions come from the same operators that they are charged with regulating. And then the Texas legislature is also responsible for holding the Railroad Commission accountable to, implementing its rules the right way. But the Texas legislature is also elected primarily from oil and gas company donations. So it's important to understand that context. The things that we hear from both the Railroad Commission and many of the legislators that are in power today are that they generally don't believe climate change is human caused. They are against carbon or methane being regulated as a pollutant at the federal level and especially at the state level. And they are starting to propose and pass laws that prevent ESG investment standards in any, state agencies or state bodies. Next. And so I think it's important to consider this. The idea behind carbon credits seems to be, well, if we can't pass federal or international or state regulations to limit carbon emissions, then let's get around this oligarchy that's preventing that so that we can solve climate change. But by doing this, we're allowing operators not to internalize the costs of cleanup. That creates a market failure. And we're spending scarce dollars and time and energy on solving only for carbon when really there's a lot of other issues caused by these unplugged wells, like groundwater contamination, soil contamination, et cetera. And so this is a statement that I'm leaving you with, and I look forward to the Q&A.
Thank you, Virginia. So yeah, we will jump into Q&A now. I'm going to start us off with an initial question as moderator. And then I'd love to turn to audience questions. So please put them in there. I'm going to start off with a question about how science can change policy, or how policy needs to adapt as technologies advance in some of these measurements, right? So Aaron, you talked about how, you were able to do some of these analyses because you had really reliable data you could get from satellites, for example. That was one, open source, but also the quality was high. So as measurement technologies advance, how does that impact the policies, and how do we improve policies to match that? And do you think we can expect trust in the VCM to increase as science improves? And I'll let you decide how you want to answer that, based on nature-based, or if you want to make analogies to the oil and gas. Both would be welcome. So I'll open that up to Aaron to start, and then Barbara and Virginia, if you'd like to join, that'd be wonderful.
Okay, so multidimensional question. I'll make just a couple points there. One is that I think part of the reason we've seen a lot of press around and attention to the challenges with RED is that it is relatively more observable from open access satellite information, right? So we can look at what's happening in the sites where we're investing in these initiatives, and we can compare them to other sites. And we don't have to worry about access to the wells, for example, to measure what's happening, because we can rely on satellite data. So I think that's been really important to learning and evaluation, and hopefully adaptive management in the forest sector, and something that the oil and gas sector needs to think about it, right? How to provide that information and that transparency. Second point, perhaps, about how policy can learn from the science. I'd note that Vera, which is the main certifier operating in the RED space, has responded to these criticisms by adapting the way that they allow project developers to set baselines. So for example, they have something now called dynamic performance benchmarks. And that, from my perspective, essentially means you could move towards setting a baseline in advance, the forecast, when you have little information and want to project high deforestation, to instead you pick places in advance that you think are reasonable comparisons, and then you track what happens in those places. So more of a counterfactual approach. That creates some of its own challenges, but it's a clear example of the sector responding to the science and trying to improve their standards and do better by the climate. The one final point is one challenge that creates, that's a great thing that policy should adapt and respond to science, but it means now in the RED sector, we have a issue of credits that were generated under previous methodologies that we've now decided aren't so good, but the people who bought those credits and invested in them under a different information set. And so the question is, how do we handle this evolution of policy and regulation as it improves in response to science? What does that mean about credits generated previously? Turn it over to someone else.
Just really quick response is that some issues can be addressed with better data, better science, and then there's some issues where the uncertainty is persistent and large. And for example, sort of out of my realm, but in the oil and gas sector, perverse incentives for the effect on regulation might be something that science doesn't address, and is something like overarching that we really need to look carefully at, as well as additionality has been a real persistent issue where science helps but doesn't solve that large uncertainty. Yeah, and I think I'll leave it at that.
I think, there are certain areas where carbon credits absolutely should not get involved. I do not think that carbon credits should be used for plugging orphaned wells. Our state has mechanisms for funding orphan well plugging already. And Texas is a really important place. I neglected to say this at the beginning, for considering these policies, because we produce 40% of the nation's oil, and we produce more greenhouse gas emissions than any other state. And so it's important to look first and foremost at Texas and how do we how do we reduce emissions here? And so, the state already has these mechanisms, but what they haven't done is increased the fees that they charge to operators or modernize the bonding amounts that they require operators to pay. And so these are really important policy changes that need to take place. And I think, the worst thing that could happen is we create a carbon market for addressing these wells, and then the regulators say the problem has been solved. We don't need to do anything, and they stop overseeing what's going on. The problem, like I showed in my slides that we're seeing today, is that there's not enough prevention going on here. We're not preventing groundwater contamination, we're reacting to it. And so we're ruining Texas aquifers in a state that has been faced with extreme drought 2 decades in a row. And so it is important for us to kind of like get after these unplugged wells for the sake of our aquifers, just as much as it is for the sake of climate.
Thank you. And I do want to give folks just a few minutes of break before we dive into our last session. So I apologize that we don't have time for more right now, but definitely want to thank you, Aaron, Barbara, and Virginia, for your remarks today. And we'll give everyone, Rebecca, 3 or 4 minutes, and then we will pop back into our last session where we will be digging into some of these complicated questions and discussions. So invite you all to rejoin in just a few minutes, and we'll end with session 5. Thank you, everyone.